Good afternoon, everyone. Today, I would like to talk about the 2021 Nobel Prize in Physics. I chose this topic because it deals with complex systems and how we can understand them using physics. The prize was awarded for groundbreaking contributions to our understanding of complex physical systems. One part of the prize focused on Earth's climate system. Climate is a complex system because it involves many interacting components, such as the atmosphere, oceans, land, and ice. These components influence each other in complicated ways, making long-term predictions difficult. Scientists developed models that describe how carbon dioxide affects global temperature. They showed that increasing levels of carbon dioxide in the atmosphere lead to a rise in global temperatures. This work provided a clear scientific basis for understanding climate change. It also allowed scientists to make more accurate predictions about future climate conditions. The other part of the prize focused on disordered systems in physics. These systems include materials such as glasses and spin systems, where the structure is not regular or predictable. At first glance, these systems seem random and difficult to analyze. However, scientists discovered that even these complex systems follow certain underlying rules. They developed mathematical methods to describe how disorder and randomness can still produce stable patterns. This work has applications not only in physics, but also in fields such as biology, neuroscience, and even machine learning. I find this discovery very interesting because it shows that complexity does not mean complete randomness. Instead, hidden structures and patterns can exist within complex systems. This idea helps us better understand natural phenomena, from climate change to brain activity. In the future, these methods may help scientists solve other complex problems. For example, they could improve weather prediction, materials science, and artificial intelligence. Even though complex systems are difficult to study, they are essential to understanding the real world. This award reminds us that physics is not only about simple systems, but also about complexity and uncertainty. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2021 Nobel Prize in Chemistry. I chose this topic because it introduces a new and powerful way to control chemical reactions without using metals. The prize was awarded for the development of asymmetric organocatalysis. Catalysts are substances that speed up chemical reactions without being consumed. They are essential in producing many important materials, including medicines and industrial chemicals. Before this discovery, most catalysts used in asymmetric synthesis were either metals or enzymes. Metal catalysts can be very effective, but they are often expensive and may cause environmental problems. Enzymes are highly selective, but they can be sensitive to temperature and other conditions, making them difficult to use in some situations. The development of organocatalysis provided a new alternative. Organocatalysts are small organic molecules that contain elements such as carbon, hydrogen, nitrogen, and oxygen. These catalysts are stable, easy to handle, and do not rely on rare metals. A key feature of this method is its ability to create molecules in a specific three-dimensional arrangement. This is important because many molecules, especially in medicine, can exist in different forms that have different effects. In some cases, one form of a molecule can be beneficial, while another form can be harmful. Asymmetric organocatalysis allows chemists to selectively produce the desired form of a molecule. This improves both the efficiency and safety of chemical production. This method has been widely applied in pharmaceutical development, where precise molecular structure is crucial. It has also contributed to more environmentally friendly chemical processes by reducing the need for heavy metals. I find this discovery very important because it provides a simpler and greener approach to chemical synthesis. It shows that small organic molecules can perform complex catalytic functions that were once thought to require metals or enzymes. In the future, organocatalysis may lead to the development of new drugs and sustainable technologies. Even though catalysts are not always visible in final products, they play a central role in modern chemistry. This award reminds us that innovative ideas can transform fundamental processes in science. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2021 Nobel Prize in Physiology or Medicine. I chose this topic because it explains how our bodies sense temperature and touch, which are essential for interacting with the environment. The prize was awarded for the discovery of receptors for temperature and touch. Our ability to feel heat, cold, and physical pressure is fundamental to survival. However, for a long time, scientists did not understand how these sensations were detected at the molecular level. Researchers discovered specific proteins in nerve cells that act as sensors. One important group of these proteins is called TRP channels. These channels respond to temperature changes. For example, one type of TRP channel is activated by heat, while another responds to cold. When activated, these channels allow ions to flow into the cell, generating electrical signals. These signals are then transmitted to the brain, where they are interpreted as temperature sensations. In addition to temperature, scientists also discovered receptors responsible for sensing mechanical pressure. These receptors are known as piezo channels. Piezo channels respond to physical forces such as touch, pressure, and stretching of the skin. When the skin is pressed or stretched, these channels open and create signals that are sent to the brain. This allows us to perceive touch and physical interaction with objects. The discovery of TRP and piezo channels revealed how external stimuli are converted into nerve signals. This process is known as sensory transduction. Understanding these mechanisms has important medical implications. For example, it may help in developing treatments for chronic pain and sensory disorders. It also contributes to our understanding of how the nervous system interacts with the environment. I find this discovery very fascinating because it explains how simple physical stimuli are transformed into complex sensations. It shows how the body connects the external world with internal perception. In the future, further research may lead to new therapies that target these sensory pathways. Even though we experience temperature and touch every day, the underlying mechanisms are highly complex. This award reminds us that even ordinary sensations are based on sophisticated biological systems. Thank you.